Hey everyone, welcome to the November Ops APAC edition, we call this. It's November 10th or November 11th, depending on where you are. Jaime is going to kick us off with this demo on this new GitLab Pages feature.
All right, so let me share my screen. Well, okay, here we are. Excuse me. So can we see my screen? Yep. Okay, cool. So I was just going to give a quick overview of how Pages is evolving and how we're able to actually serve content from object storage. And this is coming from a zip archive as well. So basically, we on deployment, we package the artifacts and we push them to object storage as a zip archive. It's there, and at the moment, we're just getting like a pre-signed URL that you can get from your object storage provider. And that is sent back to Pages, and then Pages does the unpacking and tries to find the file, and then it serves it. So I'm just going to walk a little bit through how this is done in the code. So I'm just going to make this a bit bigger. So just a bit of background here. Like there was a long discussion a few months ago where should we just serve the objects file by file, or should we just go with this approach of having them packaged in a zip archive and make it just one file and access it? We have a very nice contribution from Jacob from the scalability team, if I remember correctly, where he kind of abstracted this concept of a VFS, which is basically a virtual file system, where we just have like a bunch of operations that we can just call, and this is attached to the current architecture and implementation in Pages, where we just try to find a file in disk. So with this kind of abstraction, we can just plug and play, kind of. we just not need to implement this interface and say, hey, for disk, we're going to have one implementation. For object storage, or as you can see on this left side, we're just calling it zip. We have a different implementation. And we have this BFS that is a root. The root is just going to tell us where in your virtual file system you're going to be reading files from. And then each root will have a few operations that these are just the basic operations that the file system will go, or well, that Pages does on the file system to try to find a file. Basically, we just try to open it. We just try to, or sometimes if it's a symbolic link, we just try to get the link information and just an else that to say, hey, does this file exist or not? Here, we did a bit of hacking to try to make it to plug it with zip and how we're actually reading those files. I'll just go through this very quickly on local. Local means we are reading things from disk. So these are a few of the operations that we do. On a file system BFS, all we're doing is like, hey, does the absolute path that we're getting exist in the current directory that we have? Now, Pages works, the way Pages works is we need to pass a root directory on startup, and that just changes the directory into that root path. And then every file that we need to access, it's going to be like a relative path that should exist in that directory. So just by doing this, else that we're just making sure that whatever file we're trying to access is gonna exist. And then in root, and for a file, it's very simple. We're just making the calls that the standard library in Go give us. So this OS package is a standard library one. So it's super simple. We're just making operations directly. We just open a file, and then if it exists, we just return it, and then something else handles the serving of the file. Now, with this idea, because it's all abstracted, the kind of like the purpose was to do this with a zip archive as well. So I'm just walking through a bit of the code here. Where am I? Right. So we basically we make a call to root to say, hey, do we get the, sorry, so this doesn't help too much. Basically, when we make a call to Gitlab, to the Gitlab instance to get, hey, for this domain, what is the location of this file, right? So the API will basically give us a path. And this path, in the case of a zip BFS, is going to be a URL. And that URL is actually just the pre-signed URL that is coming from object storage. So this is just, the path looks something like this. I don't know, S3 or GCS, blah, 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 with a few arguments there. Then we just basically use the key, and we try to find or open the archive. Now we're doing a bit of caching here in memory, just to reduce the number of calls that we're making to object storage and to the backend there. And here's a bit of the logic that is doing that. So we basically just say find or create archive. We call the cache and say, hey, does the archive exist? And if we find it, we do a bit of operations here. If we need to, we actually refresh the item. So if it's in a certain period of time, we can actually refresh that. And we just keep it in the cache a bit longer. If not, this is where we start a new operation and say, hey, we're going to do a new archive. So the archive, this is just metadata, but the important part is outside of this, which I'll just go back to in a sec. Here. Once we have this zip archive, we just call it an open archive. And basically what we're doing here is we do a bit of checking. Have we opened this archive before? Is this a concurrent request? Is the archive still opening? Assuming it's not, so it's the first time we receive this request, we're just gonna go and say, hey, read the archive. And this is taking this URL. And what we're doing is we created this other package called HTTP range that it handles things as resources. So whatever we say, this is your resource, this is the URL for your resource. And it does a bit of logic to actually make the request to object storage, read the contents, and give them back as something that we can actually read and iterate. So yeah, I think I spoke about this HTTP range before in a previous demo. So if anyone is interested, I think it's back in the recordings for that demo, maybe a couple of months ago. But so basically here, we're just saying we implemented this zip reader. This is from the standard library. It actually takes this interface as input. So it's just a reader add. So basically this range reader function here is just giving us an IO reader that we can use directly with the standard library. So this is very helpful because we don't need to worry about unpacking the zip archive or anything. That's actually done by the standard library. And that once this is done, we actually just iterate over all the files that exist in the archive. There's a bit here is the slowest part, I would say. Okay, we have a to-do there if anyone's interested. Basically, we just say, hey, from all the files that exist in this archive, give me the file header. And we would just know, hey, this file has this metadata information, right? And this is how we basically unpack all the files. And this is what we actually cache. So where am I? Yep. So this is all the unpacking. Once the read archive is done, let me go back a little bit. Yeah, we're using a bit of channels here just to make sure once we complete operations, we just return. It's all good. And once we're done with that, let me try to open. Let me find the open operation from the BFS. So because all this is abstracted in the first interface, well, second interface that I showed you, we just say, we're just going to make a call to open, and this is just a file name. And what we're just going to try to do is find the file in that directory, well, in that map of that cache that we save, where we keep all the files and the metadata for that. And we just do a few, checks. It's not a file, it not exists. The daemon just handles that, and then make sure we can just, if it's a directory, for example, we just make sure that pages says, hey, this is a directory, redirect to try to find the index file, for example, if it not exists. And we're also just serving regular files. And here, yeah, so this is a bit of some of the improvements that we have done here. Basically, for a zip archive, you have a file name, and the header will tell you where the offset of that file is. So we can just say, hey, give me this from this byte to this byte, and we make a request to object storage, and that the response will just give us that specific range, right? And that's how we can actually serve just a small, just that file without having to, open the full archive again and trying to download or unzip it or whatever we need to do there. And yeah, so this is actually just done by pages. This open just give us a file, and this file is just has some operations, and as you can see, it's just a reader and a closer, and that's all the standard library needs to actually serve a file. So when this is sent back to whoever is doing this request, serving this file, just calls the regular operations in it, and we can actually just write that directly into the buffer that is writing back the response. So yeah, it's actually simple in a way. Yeah, anyone has questions so far?
So this is really cool. Thanks, Jaime. You mentioned something about the cache, and I'm curious where that gets cached, or where that lives. Is that in like the pages node itself?
Yeah. So we're caching everything in memory right now.
Okay.
So here, I'll show you at the top.
So if you were running like multiple pages nodes, you'd have multiple copies of the same cache there. Yeah.
Yeah. Okay. So in production, we have 8 nodes of pages, and yeah, every node will have to cache. So if we get a request for the same domain in all 8 nodes, we would see those.
Okay.
There will be cache in those 8 nodes.
Yeah.
So yeah, we don't have a central there.
Yeah. Well, yeah, that totally makes sense. So cool.
All right. Yeah, and we just have a bunch of logic here to, like, how can when do we expire items? When do we refresh them? When do we clean them? And like, it's kind of the work that we have pending in order to move this forward.
Nice.
But yeah, this has been working in production for at least 2-3 weeks now, where we're serving all of this. We're serving from the artifacts right now, but the idea is on deployment of pages projects, where we'll actually send them to their specific bucket in object storage.
Okay. How many, like, is this on all projects right now in production? Or is it a percentage rollout?
So we did percentage rollout, and it's now on 100%, but we only serve if we have the archive present in object storage.
Got
So
it. Okay.
if there's a few projects that are very old that haven't been redeployed and the archives were clean, we're just serving from disk. Yeah.
Got it. Okay. Cool.
And yeah, we have a few cool metrics on how this SIP is working and how it's behaving, and things have been looking pretty nice. I'll link this issue in the agenda, and if anyone is interested, there's a bunch of graphs in there that are very nice.
Awesome. Any other questions anyone has? Cool. All right. Well, we'll move on then. Thanks, Jaime. And Tom, you're up.
Let me share my screen. Desktop one. Can you all see my screen all right? Cool. So this is just a quick introduction to a whole new service called the Gitlab Kubernetes agent. It has a few use cases, but we've only implemented one use case, which is GitOps deployments. So the idea is that a developer or a maintainer will commit their changes to Git, to a Git repository, and then the agent will take those commits and use those to update the deployment in the Kubernetes cluster. This is similar to other kind of GitOps tools, such as Argo or Weaveworks Flux, basically. Yeah. So so when I say GitOps, it's actually short for GitOps deployment to a Kubernetes cluster. Right? Cool. So it's very new. It's a kind of a first release. It's currently 11 parts via GitLab charts and Omnibus. We're trying to roll this out to gitlab.com, which is our main target market, I guess, because it's sort of useful mainly for people who don't necessarily want to open up their production infrastructure to the whole internet, including say gitlab.com, which is kind of traditionally how people would prefer it anyway. They want to keep their production infrastructure internal and be able to deploy from within their network instead of having an external thing deployed to their network. So this is what the agent allows you to do. So I won't run through the whole thing, but basically there's two components that's of use here. The first component is what we call the Gitlab. Let's go to the architecture. So this is a repo. It's a Go code base, and there's two basic components to GitLab agent. The first component is KAS, or short for Kubernetes Agent Server, and that sits with GitLab itself. So it can communicate with GitLab to get authorization, and it also communicates to GitLab directly to get the kind of the contents of the repository. And then the second component is an agent, also written in Go, that the user installs onto their cluster, onto their Kubernetes cluster. And that agent, what its responsibility is to poll KAS to see if there's any new commits, new files to be synced. If it does, then KAS will send the contents of the file to agent K, and agent K will sync those contents or apply those as Kubernetes resources. So for example, so here's an example of a Kubernetes resource. If you're not familiar, So in here we have a deployment Kubernetes resource, and it's the point of this deployment is to deploy 2 pods of the Nginx image, of the Nginx 1.14 image. So to demo this, so what we have currently is really MVC. So we have the cast set up, but there's no kind of status going on. So what we have is that we have the repository set up, and you can make commits to the repository, and the agent will automatically pick up the any changes or new files as well. So in order to show status, we need to look at pod logs for the agent. So I'm using K9S just to show pod logs easily, but you can also just go Q control logs -F this pod to see. So this is a Gitlab's chart deployment. You can see various kind of pods, such as the most relevant will be the web service pods, which host both Workhorse and also the Rails Pumas server. There's also Sidekick one, Postgres, and then for us, that's more important thing is the relevant thing is CAS. So we have 2 CAS servers. And if you look at the logs, you can see that it is, this is basically polling GitLab to see whether there's any new config information. And then this is where it says I've detected a new commit on a GitHub repo. So I'm going to do something about it. So I've kind of set things up previously. So we follow the setup. The first thing that we need to do is enable CAS, which is that. Currently is not enabled by default. It's because it's still pretty MVC. The plan is to enable it by default, at least probably soon after we roll out to gitlab.com. So we're done. Following kind of GitOps, we create a config.yaml file. So I've created that here. And this config.yaml file tells this CAS server what other project to watch. You can watch many different projects, which path potentially, and also other things as well that's coming in the future. And then the other thing that we need to do is create an agent record. So we currently don't have a UI for that, but we can use GraphQL to do that. So if I open the GraphQL interface, no. GraphQL Explorer. So I've already created one, so we don't need to do that, but we can at least sort of list the agents, which is, what's the query again? Query. Let me look up the reference, sorry. Agent. Project first. Path. That's me every time. Okay, cool. So you can see that we have one agent. Maybe we want a name as well, just to show you. View name doesn't exist. Cluster agents. Okay, anyway, that's not important. Yep, name is here. Okay. So the name is agent one. That's kind of important because by convention, we expect the name to match the config YAML for that. So if you install a second agent, for example, there'll be a second folder containing a different config. So I've installed the agent in a different cluster. So if I switch to a different cluster, which is the agent one cluster, it takes a while to do all this. So that's why I set it up previously. So to install the agent, it's actually quite fast, sorry, but the others is quite. So we basically just keep control apply this file, and I've done that previously as well. So if you can look at the pod logs, it's got various messages. It wasn't able to connect, but sometimes it drops the connections. So once we have the agent connected and it's successfully dialing back to this GitLab, which is not gitlab.com, by the way, it is my own instance, then it can start fetching new commits. So in here, it's referring to the root manifest 1 project. So let's go to the root manifest 1 project, which we have a manifest YAML. And it's already got a manifest. So in theory, it should have already applied the Nginx deployment. You can see that. Yeah, it already does. So it already has 2 Nginx deployment ports. So if I make a commit right now and say make a change to bump the replica up to 3 ports, for example, it should pick it up very, very quickly. So if you look at the logs, there you can see the, let me wrap it. You can see that it's receiving some state, some files, and then it's deploying the Nginx deployment resource as well. So yeah, so that's basically Kubernetes agent for you. The other thing is that you can configure this agent to use completely Kubernetes native permissions. So if you want to configure the agent to only restrict it to be able to deploy to one namespace, you can, or you can give it the permissions to deploy to the whole cluster. It's up to you, really. Yeah.
So basically, this is just on commit, right? Like there's no pipeline running or anything.
Yeah, that's correct. Yeah, it's completely different. Yeah, it's based on commits.
Yeah, interesting. I haven't seen this before.
So
yeah,
I guess in practice, what you would do is you would have your pipeline run on a merge request, and then when you merge that in to master is when like this commit would get picked up. You might still run the pipeline on master, so you might deploy before that pipeline is done. Sounds like.
Yeah, correct.
Okay.
Correct. But then we're thinking of trying to see how for non-master branches as well, so how we can kind of enable that review apps. But really, it's just another deployment. The most popular way of deploying Kubernetes resources is Helm. a library called Helm. And Helm is a generator. It generates and applies those Kubernetes resources as well. So let me share my screen again. So these things here are not very typical in that most, no one handwrites YAML, it's just too tedious. So most people would have templates where you can fill in like variables for things, values like that. And this is currently not supported at all with Kubernetes agent, our Kubernetes agent, Gitlab Kubernetes agent. So there possibly will be some CI to have a project to generate the thing and then commit it. So maybe like a multi-project pipeline even to do that. So yeah, that part is still unsolved, or we leave it. We have that freedom or the flexibility for users to do whatever they like in that department.
How often is this polling? It seems really fast.
It's currently polling at every 20 seconds.
Oh, 20 seconds.
It's
Okay.
really, yeah. But it's configurable. So
okay.
But the configurations sits at the server end.
Okay, got it. Nice.
Yeah, 20 seconds probably too extreme for Gitlab.com, so we probably would tune it up. yeah.
Yeah. What happens if you've got some sort of deploy happening and you get another commit at the same time, or like while that's going? Like is that something that Kubernetes manages itself?
No, it doesn't. So that's part of our syncing process. So currently, what it's doing a first in, first out thing. So it finishes the current commit, applies it, and then it gets
moves on to the
another
next one right away.
Yeah. So it won't have some sort of concurrency problem.
Okay.
Yeah,
that makes sense.
In that department.
Cool. Nice.
Yeah.
Right.
So there's many more to come, but this is very preliminary.
Yeah, it's a great start.
Yep. Thanks. I forgot to mention, like this is a real group effort, led by Mikhail from the configuration team, and others as well. You can see it's a completely new service, so we basically touch other things like charts, omnibus, the infrastructure. So the whole team basically contributed to all parts of those things.
Nice.
Yeah. This is not me
right.
doing it. Yeah.
So it's a big project for sure.
I'd be interested to know a bit more and get involved in there. It'd be nice.
Yeah. Yeah. So I've posted links in the issue. So if you want to know more in the CI/CD, in the ops demo issue. So there's links to the docs, there's links to the repo, and there's also a channel as well where you can chat. Yep.
Awesome. Okay. Cool. I'll link those into the agenda too, so we can see it there.
Oh, thanks.
Yeah. Okay. Great demos, everyone. Any other questions before we call it a day? All right. Well, cool. Thanks again for presenting, and we'll see you all next month then.
All right. Thank you.
Thanks. Bye.